Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 2 class. It is 4.1, Day 3, Exponential Growth and Decay. Basically, in this lesson, all we're going to do is we are going to determine whether each equation is an exponential growth or an exponential decay, and then we're going to solve them. Okay? So the exponential function is y equals a times b raised to the x, where a is, again, the initial amount, and b is the base. All right, so we need to decide if the following functions represent exponential growth or decay, and then evaluate the functions for the given values. Remember that how to determine whether it's exponential growth or decay has to do with our base. So in problem 1, I have 4 over 3. If the base is 1 or larger, then it's going to be growth. So the first problem is going to be growth. The second problem, my base is 7, so that's also going to be growth. The third problem is 0.8, so that is going to be decay. All right, now to problem number 1, we need to solve the equation. So what we're going to do is y equals 3 times 4 over 3 squared. I can type that straight through in my calculator. If I do, I will end up with 16 over 3, and that would be our answer. Okay. On to problem 2. We have y equals 1/2. So y equals 1/2 times 7 raised to the 4th power. If we type that straight through in our calculator, what we're going to end up with here is such a large number. It would be 1200.5. That would be extremely hard to write as a fraction. So on that one, it's not overly a problem that you write it as 1200.5. Do leave it as 1200.5, though. Do not round up to 1201 because that would not work. All right, on to number 3. We have y equals 62 times 0.8 raised to the 0 power. Remember, anytime that I have something raised to the 0 power, it's going to be 1. So y would just equal 62. Again, you only have to give me the top and bottom line there because you can type all those through straight into your calculator. All right, on to problem 4. Problem 4, we start with 1/2 times 4 raised to the x power. Well, let's just do the -1 problem first. If I have 1/2 times 4 to the -1st, I would end up with 1/2 times 1 over 4, which would get me 1 over 8. So I have 1 over 8. Now remember, I can go right now and take 1 over 8 times 4 if I want, or because this is 0 would be the next number I plug in for x, it's almost as easy just to take 1/2 times 4 raised to the 0 power, which would get me 1/2 times 1, which is 1/2. All right, now I can go ahead and start using my trick where I multiply each one of the sections by the base. So 1/8 times, my base is 4, remember. 1/8 times 4 is 1/2. 1/2 times 4 would be 2. 2 times 4 would be 8, and 8 times 4 would be 32. You can do it that way, or you could type each one of those individually in, and you will come up with the same answers. So now to graph it, 1/8 I'm going to put right on that tick mark, 1/2 just above it. 2 needs to be right about the middle. When x is 2, my y would be 8. And when x is 3, my y would be 32. I want to get as close to the x-axis as possible. Connect all my points, and I am done. Remember, my domain and range have been the same every single time. Since my x goes on forever in the negative and to the positive, it would be double bar r, all real. My range does not touch or cross over the x-axis, so my y's are greater than 0. On to problem 5. I have 20 times 1/2 raised to the x power. If I put -1 in first for x, I would have 20 times 1/2 raised to the -1st, which would get me 20 times 2, which is 40. Now, if I multiply 40 by my base, I would end up 40 times 1/2 would be 20. 20 times 1/2 would be 10. 10 times 1/2 would be 5. Now, 1/2 of 5, some of you might know that as 2.5 right away, or 2 1/2. Or you could type it straight in your calculator. 2 times 2 is 4, plus 1 would be 5/2. That's how I'd like you to write that. Okay. Remember that all I did is I multiplied each by 1/2, which is my base. Or, again, you could type each one of the x values, plug each one of the x values in for x and type that straight through in your calculator. Completely up to you. So when x is -1, my y is 40. When x is 0, my y is 20. When x is 1, it's 10. When x is 2, it's 5. And when x is 3, it is 2.5, which would be about halfway through. Go ahead and connect all of our points. Remember to get really close to 0, but we don't want to touch it. Again, my domain would be all real because my x's go on forever to the negative and on forever to the positive. My range would be still y is greater than 0 because I do not touch 0 or cross over. That is the end of our lesson. It was a really quick, easy one. If you have any questions on this still, please make sure you're coming in and seeing me. Again, your two different ways to go ahead and calculate your table is to put all the x values in for x and type them through in your calculator, or you can use our trick where we take each y value and multiply by the base. Completely up to you. Thank you very much for watching the video, and have a great day.